Good evening, dear students. So today we are going to start with we are going to solve the model question paper. Okay. So you know that the chemistry CET paper. Okay, it will be what? It will be based on your Q1 as well as Q2 portion, right? So we are going to see a model question paper. Okay, here in this model question paper, some of the questions are from the deleted portion. So those questions will be skipping. Okay, and only we are going to see the questions on the your which portion is included. Okay, both from Q1 as well as Q2. Okay. So PU1 as well as PU2 portion will be there, and you will be having 60 questions. As you know, for your CET, okay, you'll be having 60 questions. So, whichever is only one correct answer you have to mark. Okay, only one correct answer you have to mark with you have to make a this what dot, dark colored dot, right, on your OMR sheet. So, there are 60 questions, okay, both from the PU1 as well as PU2. So let us solve the questions. Yes, students have come. It's only 5 students have come. Okay. So one more minute we will wait and then we will start. Okay. Okay. So let us start. Okay. So let us start with the questions. Okay, so this is the first question. So there is a compound given. Okay, you can see a structure of a molecule. Okay, so you need to tell the IUPAC name. So there are 4 options. Okay, so you tell the IUPAC name of the following compound. Please tell the IUPAC name of the following compound. So I want the answers from you also. Okay, so already we have discussed the type of question. Okay, on all the particular chapters from the chemistry subject. So what will be the answer for this? So a structure is given, okay, here. So can you tell me the IUPAC name? What is the IUPAC name? What is the IUPAC name? How you're going to name that compound? Yes, nobody knows. 6 students are there. 6 students, nobody knows. CH3, CHOH, CH2, CH, COH, CH3. So there are 4 options. First one is 4-hydroxy 1-methyl pentanoic acid. 4-hydroxy 2-methyl pentanoic acid. Third one 2-hydroxy 4-methyl pentanoic acid. And fourth one is 2-hydroxy 2-methyl pentanoic acid. Yes. How are you going to name it? How are you going to name this compound, students? Try. If your answer is wrong, also no problem, but you need to try. Yes, try. Okay. Sri Varuni has answered. Okay, and her answer is one, two. Okay. Brindu has also answered. Yes, both the answers are correct. Okay, so let us see here. Okay, when you are naming the compound. Okay. Okay, so one more answer. Amulya has also answered. Very good. Okay. So yes, all the three members have answered it right. Yes, others want to answer, or should I tell you the answer? So how you're going to name or how you're going to give the IUPAC nomenclature. Okay, according to the IUPAC. Okay, so how we are going to name this compound? Now here, okay, okay, I'll tell you we'll go for the answer. So here two functional groups are there. Okay, one is the hydroxy group, another is the carboxylic group, right? Carboxylic acid group, and another is the hydroxy group. So when you are giving the preference, okay, according to the functional group, when the preference you're going to see, so the carboxylic acid is given more preference. Okay, the priority, when you check the priority list of the different functional group, the carboxylic acid, okay, carboxylic acid has the more priority. The priority is given more than the hydroxy group. So this is taken as the parent chain. Okay, your carboxylic acid is taken as a parent chain, and your hydroxy group will be taken as a side chain. Okay, so how we are going to name this compound now? So start numbering the compound. Okay, so let us start. So as I'm mentioning that your carboxylic acid will be what? It will be a parent chain. So your parent chain should get the less number. Okay, the numbering should be less there. So if I number from here, it will get 2. Okay, if I number from this side, 1, 2, 3, and 4. So the carboxylic acid will get the more number, right? So the substituent on the that will be more. So let us start numbering from the right hand side. Okay, so it will be 1, 2, 3, 4, and 5. Okay, now first what you have to see, you have to see the substituent. So which is a substituent here? Your hydroxy group. So how you are going to name it? So it is 4-hydroxy. Okay, 4-hydroxy. Then what you have? 1,4-hydroxy. Then you have 1-methyl. Okay, they have take. Sorry, just a second. Okay, here. So 1, 2. Okay, so 4-hydroxy, 1 methyl. Okay, and what? Pentanoic acid and pentanoic acid. Okay, I have written the structure wrong here. So this should come here, this should come here. Okay, so CH, COOH, and here is CH3. Okay, so what it is? So 1, 2. Okay, so 1 methyl. Okay, so you are going to get 4-hydroxy, 1-methyl pentanoic acid. Okay, so this is the name of the compound. So this is the name of the compound. So yes, option number 1. Okay, option number 1 is the correct answer. Option number 1. So 4-hydroxy. Okay, 4-hydroxy, 1-methyl pentanoic acid. Okay, yes. So let us go for the next one. Alkali metals. Alkali metals have negative reduction potential. I think question passed. Okay, just a second. Okay, now you can see. Now I think you can see. Fine. So alkali metals. Okay. So alkali metals have negative reduction potential and hence they behave as. So alkali metals, they are having negative reduction potential and hence they behave as 1, oxidizing agent, 2, Lewis basis, 3, reducing agent, and 4, electrolytes. Okay. Alkali metals have negative reduction potential and hence they behave as. Okay, reducing agent. Shivaruni and Vandana have answered as reducing agents. Jay Lakshmi has also answered as reducing agent. Amulya has also answered as reducing agent. So alkali metals have negative reduction potential. Why? What is the reason? So these are the four options. Okay, as a oxidizing agent, Lewis basis, reducing agent, and electrolytes. So what is the answer? So yes, reducing agent is the correct answer. So why it is the reducing agent? Alkali metals have negative reduction potential. Why they are said to be reducing agent? What is the role of reducing agent? Reducing agent means what? They will reduce other and itself undergoes oxidation. So alkali metals, they act as reducing agent, okay, by undergoing the reduction. So here when you see the your this, okay, the reduction potential, it will be in negative. Okay, so they will have low values of oxidation potential. Okay, so as compared to that of your alkaline earth metals. So alkali metals, they have negative reduction potential and hence they behave as reducing agent. Reducing agent means they will undergo, it will reduce other and itself undergoes oxidation. So it will undergo what? Reduction. Okay. Yes, so option number 3 is the correct answer. So yes, okay, what one? Okay, third one you skip. This is from states of, okay. So go for the fourth one. Okay, tell me the fourth answer. Cycloalkane formed when 1,4-dibromopentane is heated with sodium is. Cycloalkane obtained, formed when 1,4-dibromopentane is heated with sodium is. First one, methyl cyclobutane. Then second one, cyclopentane. Third one, cyclobutane. And fourth one is methyl cyclopentane. Okay. Vivo, please update your name. Okay. Jay Lakshmi has answered as 2. Shri Vandana has answered as 4. Shri Varun has answered as 1. Okay, 4 different answers I have got. Amulya has answered as 1. Okay. Okay. Cycloalkane formed when 1,4-dibromopentane is heated with your sodium is. Vandana has also answered as 1. Cycloalkane. Cycloalkane formed when? Yes. Any more answers? Yes. Any more answers? So this is your cycloalkane. Okay, a cycloalkane when it is obtained when you have a dibromo formed when 1,4-dibromopentane. Okay, 1,4-dibromopentane is, okay. Aditya has answered as 1. Okay, fine. So your cycloalkane formed when 1,4-dibromo butane. So let me write the structure of 1,4-dibromobutane. So this is a pentane, 1,4-dibromopentane. So 1, 2, 3, 4. Okay. Then this is CH3, your one CH3. So this is a pentane, 1, 2, 3, 4, 5, 6, I've written. Okay. So this is your pentane. Pentane means 1, 2, 3, 4, 5. Okay, 5 carbon. Now at 1 and 1, 2, 3, 4. At 1 and 4 position, you have your what? You have your Br groups. Okay. So CH2Br and CHBr. Okay. So this is your what? 1,4-dibromopentane. So what is happening? This 1,4-dibromopentane, you have heated with sodium. Okay. You have heated with sodium. Okay, you have heated with sodium. What you are going to get? What you are going to get when you heat it with sodium? Okay, so what will happen? So there will be a, so this, okay, so this will join and this will be your, so like this, a cyclo, this is octane. Okay, so CH3. So you are going to get a cycloalkane. So which is the name of the cycloalkane? So 1, 2, 3, and 4. So it is what? Methyl. Okay, a substituent is there, methyl. Okay, so this is the substituent, that is methyl, and cyclo 4 carbons means butane. Okay, cyclobutane. So this is the answer. So cycloalkane formed when 1,4-dibromopentane is heated with sodium is methyl cyclobutane. Okay, so yes, whoever have answered as 1 is the correct answer. Okay, it is the, these options are wrong. Okay, but the answer is cyclobutane. Okay, so it is the cyclobutane. Okay, let us go for the next one. In the reaction, 2FeSO4 plus H2SO4 plus H2O2 giving you Fe2SO4 thrice plus 2H2O. The oxidizing agent is, so in this reaction, which is the oxidizing agent? So what is oxidizing agent? Oxidizing agent, it oxidizes other and itself undergoes reduction. Okay, so these are the 4 options. Yes, tell me. In the reaction, in the reaction, 2FeSO4 plus H2SO4 plus H2O2 giving you Fe2SO4 thrice plus 2H2O. The oxidizing agent is, what is oxidizing agent? Okay, Jayalakshmi Aditya has answered as H2O2. In the, so this is the, what is oxidizing agent? It oxidizes other. Okay, it will undergo oxidation and itself undergoes reduction. So in this reaction, okay, so you can see that FeSO4, okay, so FeSO4, so this is plus 2, okay, and here SO4 thrice, so Fe plus 2, SO4 thrice, okay, so here H2O. So if you see the oxidizing this, so this is plus 1, okay, each is plus 1, so this is minus 2, this is also plus 1, so this is here what? Oxygen is, each oxygen is minus 1. Okay, so here you can see. Okay, so this is what your H2O2 is a oxidizing agent. Okay, it will oxidize other and itself undergoes reduction. Okay, so hydrogen peroxide, H2O2 is called as hydrogen peroxide. It is a strong oxidant. Okay, it is a strong oxidant in both your acidic as well as alkaline medium. Okay, so what it is doing, your ferrous, okay, which is Fe plus 2 has been what oxidized to ferric, okay, Fe plus 3, okay, and your water, which is that is your H2O2 is reduced to H2O. Okay, so your H2O2 it will is reduced to what? It is reduced to H2O. So H2O2 is the oxidizing agent. Okay, yes, so option number 3 is the correct answer. Okay, option number 3. Okay. Given thermochemical equation, okay, heat of decomposition of water is in the given thermochemical equation. So this is a thermochemical equation given 2H2, okay, 2H2 plus O2 gas giving you H2O liquid. Delta H is equals to minus 571.6 kilojoules. Heat of decomposition of water is. What is the heat of decomposition of water? How you are going to find out? You have to delta H is what? Enthalpy change. Change in enthalpy. So a thermochemical equation is given. Okay. So thermochemical equation. So you have to tell the heat of decomposition of water. How the So the you have to tell the energy, okay, required. So that is the energy that is changed, okay, between the system and the surrounding is represented by the delta H, okay. That is your enthalpy change. So how you are going to give the answer for this? Decomposition, heat of decomposition of water. Decomposition of water means 2H2O, okay, 2H2O giving you H2 gas plus half O2. Okay, gas. So here your water which is liquid, okay, your water which is liquid. So decomposition. Okay, so what you are going to do? So you are going to, so your delta H is given. So if I divide by 1.6 by 2, okay. So if I divide it by 2, so what I'm going to get? Yes. So 571.6. So your change in enthalpy, okay, for decomposition of water, if you divide it by 2, okay. So what I'm doing, whatever the reaction is given, I have reversed the reaction, okay, and I'm going to, what I'm going to divide it by 2. When I'm dividing it by 2, okay, and when I've reversed the reaction, the your minus sign, okay, the sign will be changed, okay, sign also will be changed. So your delta H sign from negative, it will be changed to positive. So what will be the answer? So if I do this 571.6 by 2, it is 285.8 kilojoules. So option number 4 plus 285.8 kilojoules. Okay. So who all have answered as 4? Amulya has answered, Aditya has answered, Vandana has answered. Very good. Okay. So yes, 4 is the correct answer. Okay. Yes. So let us go for the next one. So seventh one. Okay. It is from the chapter polymers. So skip it. Go for the eighth one. Tell me the electronic configuration of copper plus 2. Copper plus 2 ion. What is the electronic configuration of copper plus 2 ion? Plus 2 means 2 electrons are lost. So what you need to do? First find the electronic configuration of what? First find the electronic configuration of your copper. Okay, and then you what you do? Minus the 2 electrons. Okay, minus the 2 electrons. See how what will be your answer? Copper. What is the copper? Copper is 29, right? Copper is 29. The electronic configuration of copper is 29. So copper will be what? Yes, it will be 3d10 4s1, argon 3d10 4s1. Okay, when copper plus 2, then it will be argon. What it will be argon? Yes, tell me. It will be one electron will be lost from here and another electron from here. It will be 3d9. So it will be argon 3d9 4s0. 3d9 4s0. 2. Answer number 2. Yes, Aditya, Sri Varuni, Amulya has answered it correct. Very good. Okay. So I hope you have understood it. Okay. So the electronic configuration, first you write it for copper, which is 29. So argon 3d10 4s1 is the electronic configuration. Okay. And then plus means you have to subtract how many? 2 electrons plus 2. So 2 electrons. So first one electron will be gone from the s orbital and then the next electron will be gone from the d orbital. Okay. So it will be 3d9. Okay. Let us go for the next one. The yield of the products, in the reaction A2 plus 2 plus 2B, okay, A2 gaseous plus 2B gaseous, there is a equilibrium sign, okay, giving you the product C gaseous plus Q kilojoules would be higher at first option is high temperature and high pressure. Second option is high temperature and low pressure. Third option is low temperature and high pressure. Fourth one is low temperature and low pressure. So this is from the chapter your okay, this is based on the concept of Le-Chatelier's principle. Remember, now recently we have solved this. So there is a reaction. So this is the reaction. Okay, that is A2 gaseous plus B2B gaseous in equilibrium. So this is from the chapter equilibrium. Okay, plus Q kilojoules would be higher at yes, it will be higher at what? What will be the answer? Okay, Sri Varuni has answered as low temperature and high, low temperature and low pressure. Okay, option number fourth one. Okay. Others? So the answer is third one, low temperature and high pressure. Okay, the answer is low temperature and high pressure. Why? What will be the reason? Sanjeevni Vandana have answered as well. No. So the yield of the products in the reaction A2 plus 2B gaseous in equilibrium giving you C gaseous plus Q kilojoules. Okay, will be more or it will be higher at low temperature and high pressure. Okay, so what will happen here? Okay, so when according to the Le-Chatelier's principle, okay, when you apply the Le-Chatelier's principle, so the when you are increasing the pressure, okay, so what will happen? Increasing the pressure, it will shift the equilibrium to the side of the your fewer moles of gas. Okay, it will so few moles of the gas. Okay, that is in this reaction you can see there are 3 moles of gas, right? Here you can see there are 3 moles of gas. Okay, so 1 mole of your A2, okay, 2 moles of your B, and 1 mole of your C. Okay, now here you can see that on the product side you have only 1 mole. Okay, you have only 1 mole, but on the reactant side you have 3 mole. So what will happen? What will happen? The pressure it will shift where? It will shift to the equilibrium. Okay, when you increase the pressure, okay, if the pressure is more, the equilibrium will shift to the side of the reactant. Okay, or that is your product, which is having fewer moles of gas. Okay, so that is because of that high pressure. So you are applying high pressure. Okay, when you are applying high pressure, what will happen? The equilibrium will shift to the product side because the number of moles are less. Then when you are seeing the temperature, okay, now here the reaction is exothermic. Okay, because the energy is released. Okay, here you can see the energy is released plus Q. Right, plus Q means the energy is released. So what will happen when you lower the temperature? What will happen? The formation of the product will be in the exothermic reaction. Okay, it will favor the formation of products in the exothermic reaction. So the reaction is exothermic. Okay, so because of that, low temperature and high pressure is applied. So this is based on the Le-Chatelier's principle. Okay. So answer number C. Answer number C is the answer. Okay. Let us go for the next one. Okay, 10th one. Mesomeric effect involves. So what do you mean by mesomeric effect, students? What do you mean by mesomeric effect? This is the question from your first year. Okay, from the hydrocarbons, no, not hydrocarbons, basic organic chemistry, first chapter of the organic chemistry. There we have studied about electromeric effect. Remember, we have studied about the electromeric effect. Then you have studied about the resonance effect, right? mesomeric effect, inductive effect. So what do you mean by your mesomeric effect? So first one, delocalization of pi electrons, delocalization of sigma electrons, third one, partial displacement of electrons, and fourth one, delocalization of pi and sigma electrons. Okay. Aditya Vandana Amulya has answered as 1. Okay. Delocalization of pi electrons. Sri Varuni has answered as fourth one. Okay. The answer is first one, correct. Delocalization of pi electron. So delocalization of pi electron is the correct answer. Okay. So mesomeric effect, what it involves? The delocalization of pi electrons. Okay. Yes. So like this, okay, so the pi electrons will delocalize. So whatever the adjacent electrons are there, okay, pi electrons are there, what will happen? The movement of pi electron takes place. Okay, so delocalization of the pi electrons will takes place across the atoms. Okay, within the same molecule, this will take place. So what will happen that time? What will happen? The complete transfer of your pi electrons or the lone pair of electrons will be taken place to the adjacent atom. So beside the atom, okay, pi electrons, whichever the atom is present, okay, or the covalent bond is present, so there the adjacent transfer will take place. So option number 1 is the correct answer. Okay. Next one, which of the following set of ions represent the collection of isoelectronic species? Isoelectronic species means same number of electrons. Isoelectronic species means what? Same number of electron. Okay. What do you mean by isoelectronic species? Same number of electrons. Okay. Which of one of the following sets of ions represents a collection of isoelectronic species? Okay. Vandana has answered as third one. What about others? Okay. Vandana Shri Sanjeevani has answered as second one. Amulya has answered as third one again. Okay. Which of the following isoelectronic species means number of electrons will be same? Okay. Any more answers? Shri Varuni has also answered as third one. Okay. So what do you mean by isoelectronic species? They contain same number of electron. Okay. So here the number of your proton, what it will do, it will determine the size of the isoelectronic atoms or the ions. Okay. Now if you see here, okay. So what is the K? Potassium. Your chlorine. Okay, let us write. Okay. So your potassium. What is the atomic number of potassium? Potassium is represented as K, right? So what is the atomic number? It is what it is. 19, right? Write down. So for 19, okay. So 19. Now K plus, okay. K plus is having what? K plus is having, so 19. K plus means 18 electron. K plus means how much? 18 electron, because 19 minus 1 will be how many? 18 electron. Now, your next is your chlorine. Chlorine is having 17. Okay, chlorine is having how many? 17. Chlorine minus. Minus means you are adding 1 electron. So it will be 17 plus 1 will be 18 electron. So whenever you have plus, that means you are subtracting. Whenever you are having minus, you are going to add 1 extra electron. Okay. Next is your Mg. What is Mg, students? What is Mg? Mg is, yes. What answer you got? Mg is 12. Okay. So 12, they have written plus 2 means 10, 12 minus 2 will be 10 electrons. Okay. It will be 10 electrons. Scandium. What about scandium? What about scandium? Okay. What about scandium? Scandium is 21. Right. Scandium is 21. So they have written plus 3. Plus 3 means again subtract 3. Okay, subtract 3. Scandium is 21 minus 3. Will be how much? 21 minus 3. 18. Okay, 18 electrons. So not first one. Okay, not first one because Mg is 10 electron. Then go for your third set. Okay, third set. K plus is 18 electron. Calcium. Okay, C for calcium. Calcium is how much? Calcium is how much, students? 20. Calcium is 20. So 20 plus 2. So 20 minus 2 will be 18 electrons. So calcium is 18. Scandium is 18. Chlorine is 18. So yes, option number 3. Option number 3. Okay. Who all have answered as option number 3 is the correct answer. So Vandana, Amulya, yes, your answers are correct. So option number 3. Okay, understood? So same number of electron. In magnesium, it was 10. So the entire set is wrong. But when you see 3, this set, K plus is 18. Calcium is 18. Okay, plus 2 means you are subtracting that many. Scandium plus 3. So 21 minus 3 is again 18. Chlorine minus. So 17 plus 1 is 18. Okay, so option number 3 is the correct answer. So yes, let us go for the next one. 13th one, go for 13th one. Methane can be converted into ethane by the reaction. How you are going to convert methane into ethane? Methane can be converted into ethane. Methane is converted into by ethane by chlorination followed by Wood's reaction. Okay, chlorination followed by Wood's reaction. So what is chlorination? Methane plus Cl2 in the presence of H nu giving you CH3Cl. Okay, CH3Cl. Now this CH3Cl, okay, what you are going to do? I'm going to react it with Wood's reaction. Okay, CHCCl, CHCCl. Okay, in the presence of Na plus Cl and CH3. Okay, so what I'm going to get? What I'm going to get in the presence of dry ether? So I'm going to get NaCl. Okay, 2 NaCl. Okay, 2 NaCl plus CH3, CH3. So option number third one, chlorination followed by Wood's reaction in the presence of dry ether. Yes, understood? So first is chlorination. Methane, I have reacted with chlorine gas in the presence of light to give you CH3Cl. Okay. Now this CH3Cl plus 2Na plus again one molecule of your Cl, that is CH3Cl. Okay, what you are going to get? What you are going to get? So Cl, CH3. Okay, so I am going to get this. Okay, that is your byproduct plus CH3, CH3. Okay, ethane. So yes, option number three. Again, option number three is the correct answer. Let us go for the next one. Intramolecular hydrogen bonding is found in. What do you mean by intra? Hydrogen bonding is formed between the negative atom. Okay. So how you can see that? Hydrogen bonding. So hydrogen bonding where you can form? It is formed between the your hydrogen atom, okay, and any other electronegative atom, okay, which is the electronegative atom like your oxygen, fluorine, okay, nitrogen. So it is like a covalent, like your dipole-dipole interaction, okay. So hydrogen bonding is like a dipole-dipole interaction, okay, and it is the attraction formed between the hydrogen atom and some other electronegative atom like your oxygen, fluorine, nitrogen. Okay. Now, in this type, two types of hydrogen bonding are there. Inter means between the two different molecules. Intra means within the same molecule. So these are the four options. Okay. Vandana has answered as two. So first option is water. When you see water molecule, okay, H2O, H when you see water molecule, so it is between the different molecules, right? You can see this is between the different molecules, water, right? The hydrogen bonding, when it is present in between different molecules, then it is called as what? Inter. I have said they have asked for intramolecular. Then salicylic, what is the structure of salicylic? Salicylic. Amulya has also answered as two. Salicylic. Yes. CHO and OH. Okay. One aldehyde and one OH group. Now, ammonia, NH3. So again, between the different molecules. So this is also wrong. This is also wrong. Benzophenone, benzophenone. Wait, let me write it properly. Benzophenone. This is benzophenone. Then salicylaldehyde. Okay, rest all we have seen. So C double bond O H O H. So if I see in this structure, okay, when we see salicylaldehyde, so C double bond O H. So you can see or you can see like this also. C double bond O and H. So here you can see the hydrogen bonding is present between the same molecule. So what did we say about the hydrogen bonding? Hydrogen bonding is like a dipole-dipole interaction between the atoms. Okay, a hydrogen atom will be attracted, okay, to the electronegative atoms, like your attractive forces are present between the hydrogen and the other electronegative atoms, like your nitrogen, oxygen, fluorine. So there are two types of hydrogen bonding. One is if the bonding is present between the same molecule, then it is called as the intra. If the bonding is present in different molecules, then it is called as inter. Now they have asked the example for a intra. Okay, that is within. So answer is 2, salicylaldehyde. Okay, the salicylaldehyde. So option number 2 is the correct answer. So yes, very good. Let us go for the next one. If 50% of the reactant is converted into product in the first reaction in 25 minutes, how much of it would react in 100 minutes? Yes, how are you going to solve this? If 50% of the reactant is converted into product, okay, in the first reaction, how much of it would react in 100 minutes? Yes, students, how are you going to answer this? First, you have to find what? First, find the half-life. Okay, find the half-life. If 50% of the reactant is converted into product in the first reaction, okay, in 25 minutes, how much of it would react in 100 minutes? So first find the half-life of the reaction. Okay, then what you do, then you have to find the half-life. Okay, by using the half-life, you have to find the amount of reactant that would react in the 100 minutes. Okay, so first step, okay, what you will do, find out the half-life. Okay, let us find the half-life of the reaction. So since 50% of the reaction, okay, 50% of reaction is converted into product. So since 50% of the reactant is converted into product, in how many minutes? In 25 minutes. Okay. The half-life of the reaction is how much? Half-life of the reaction is 25 minutes. Okay. Half-life of the reaction is 25 minutes because already the half reaction is converted. So half-life is 25 minutes. Now, so from uh, so, uh, so from 100, okay, to convert into 50, it took 25 minutes. So from 50 again to convert into its half, that is 25, it took 25 minutes. From 25 to convert into its half, that is 12.5, it took 25 minutes. Then 12.5, its half is 6.25. It took 25 minutes. So total it was 100 minutes. So how much of it would react in 100 minutes is 6.25, right? So 6.25, so 6.2% to 5% of reactant would react in 100 minutes, right? Now here, so 6.25, so 100 minus 6.25, so how much? Find out. 100 minus 6.25, how much you're going to get? 100 minus 6.25, 93.75. Okay. How much it would react in 100 minutes? It is 93.75%. So first one. Okay. Got it? So 50% of the reactant is converted into product in first reaction. Okay. How much of it would react in 100 minutes? They have asked. So first what you have to do, first find out the half-life. Half-life is what? So already the 50% of reactant is converted to product. So the half-life of the half-life of the reaction is 25 minutes. So from 100 to convert into its half, it took 25. Again from 50 to convert into its half, 25, it took again 25 minutes. So like this 25, 25, okay, 25, 25, 25, and 25. Total it was 100 minutes. So after 100 minutes, 6.25% of this, okay, reactant would react, right, in 100 minutes. So if 50% of the reaction is converted into a product in the first order reaction in 25 minutes, then how much it would react is 93.75%. So option number 1. Okay, fine. So yes, Vandana has answered. Very good. Okay. Understood up to here. So the number of optical isomers for the compound. So this is a compound. Tell me the number of optical isomers. CH3, CHBr, CHBr, and COOH. So how many number of optical isomers is required for this compound, particular compound? Okay, number of optical isomers, how we are going to calculate? First find out the chiral center, students. Okay, Vandana has answered as 4. Amulya has also answered as 4th. Okay. So the find out the optical isomers, number of chiral centers. First, it is 2 raised to n. Okay, number of optical isomers, it can be calculated by this formula, where n is the number of chiral centers. Find out the chiral centers. So to find out the optical this isomers, the formula is 2 raised to n. So n is the number of chiral centers. Okay. So first, so CH3. So here all the atoms are same. So this is not a chiral center. Okay. So you can see there are 2 chiral centers. Okay. If I consider this, so 1, 2, 3, and 4. Okay. 4 different atoms. So this is one chiral center. Then if I take this one, so this is 1, 2, 3, sorry, 1, 2, 3, and 4. Right. So this is another chiral center. So there are 2 chiral centers. So n is equals to 2. N is equals to 2. So 2 raised to 2 is how much? 2 square is 4. So yes, option number 4 is the answer. Very good. Okay, remember that. Fine. So 17th one skip. 18th one. The rate of reaction increases with rise in temperature because of. The rate of reaction increases with the rise in temperature because of A, increase in the number of activated molecules. 2, increase in energy of activation. 3, decrease in energy of activation. 4th, increase in the number of effective collisions. So how the rate of reaction increases when you increase the temperature? Yes. So when you increase the temperature, okay, when there is increase in rise in temperature, the rate of the reaction also increases. What will happen? The number effective collisions also will be more. So that there will be increase in number of activated molecules. Okay. So increase in the number of effective collisions. So yes, you can see, I think I feel option number 1 and 4th. Okay. Yes. So you can feel the rate of reaction increases. So all these options are correct. 1, 3, and 4. Okay. Increase in number of activated molecules. So when there is increase in rise in temperature, the rate of energy increases because there is increase in number of activated molecules. The number of collision, effective collisions also will be more, and there will be increase in energy of activation. Okay. So all these answers are correct. So if you mark any one also answer, they'll give you correct answer. Okay, fine. Yes. Okay, fine. So the remaining questions, okay, we will be discussing in the next class. Any doubts up to your? Yes, any doubts up to your? Okay, so the remaining questions we'll be discussing in the next class. Okay. So yes, so I shall end this session here. We will meet in the next class. Thank you.